The sun, the heart of our solar system, has been burning for about 4.6 billion years, but it won't last forever. Like all stars, the sun will eventually run out of fuel and undergo dramatic changes in its later life. One of the most significant phases in the sun's life cycle will be its transformation into a red giant, an event that is expected to occur in roughly 5 billion years. This phase will have profound effects on the solar system, particularly on Earth. Here's a closer look at the sun's future and how these changes will affect our planet. The sun is currently in the middle of its main sequence phase, the longest and most stable period in a star's life. In this phase, the sun generates energy by fusing hydrogen into helium in its core. This process releases immense energy, providing the heat and light necessary for life on Earth. However, the hydrogen fuel in the sun's core is finite. As it burns through this hydrogen, the balance between nuclear fusion, which pushes outward, and gravity, which pulls inward, will eventually shift, leading to the next stages of its evolution. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core. When this happens, nuclear fusion in the core will stop, causing the core to contract under its own gravity. At the same time, the outer layers of the sun will expand as hydrogen fusion continues in a shell around the core. As a result, the sun will swell dramatically, turning into a red giant. During the red giant phase, the sun will become enormous, growing to 100 to 200 times its current size. Its outer layers will puff out, and the sun will turn cooler and redder in color. Despite this cooler temperature, the sheer increase in size will cause the sun's outer envelope to engulf the inner planets, potentially including Mercury, Venus, and possibly Earth. Key impacts of the red giant phase on Earth. 1. Increased luminosity. The sun's luminosity brightness will increase significantly during the red giant phase. This increase in energy output will have devastating effects on Earth, even before the sun expands to engulf it. 2. Boiling oceans. As the sun becomes brighter, the heat will rise dramatically on Earth. Within the next billion years, well before the red giant phase, this increased heat will cause the oceans to evaporate, leading to a runaway greenhouse effect. Water vapor, a potent greenhouse gas, will trap even more heat, making Earth unbearably hot and uninhabitable. 3. Loss of atmosphere. As Earth's surface heats up, the atmosphere will likely be stripped away by the sun's intense solar winds. Any remaining life, if it exists, will struggle to survive under such extreme conditions. Eventually, Earth's surface will become a scorched, barren desert. 4. Engulfment. During the later stages of the red giant phase, the sun's outer layers might expand enough to reach Earth's orbit. Even if Earth is not directly engulfed, the planet will be subjected to intense heat and radiation, possibly causing it to spiral inward toward the sun as it loses orbital stability due to the sun's mass loss during this phase. Once the sun has exhausted the hydrogen in its outer shell, it will begin to fuse helium into carbon and oxygen in a process called the helium flash. This will be a short-lived but intense phase. However, the sun is not massive enough to fuse elements beyond carbon and oxygen, so this phase won't last long. Eventually, the outer layers of the sun will be ejected into space, forming a beautiful structure known as a planetary nebula. The core of the sun will remain behind, becoming an extremely hot, dense remnant called a white dwarf. What happens to Earth after the red giant phase? 1. If Earth survives. If Earth is not engulfed during the red giant phase, it will likely be a cold, dead planet orbiting a white dwarf. With no heat source and no atmosphere, Earth will be a lifeless, frozen world. Over time, gravitational interactions with other planets or stars could either stabilize or destabilize Earth's orbit, but the planet will never regain its former habitability. 2. If Earth is destroyed. If the sun expands enough to swallow Earth, the planet will be incinerated. Its material may be absorbed into the sun's outer layers or ejected into space as part of the planetary nebula. After the sun sheds its outer layers, all that will be left is the core, which will cool and shrink into a white dwarf. A white dwarf is a small, dense star about the size of Earth, but with a mass comparable to that of the Sun. It will no longer produce energy through nuclear fusion, but will glow dimly from leftover heat. Over billions of years, the white dwarf will gradually cool and fade, eventually becoming a cold, dark black dwarf, a theoretical object that no longer emits light or heat. However, since the universe is only about 13.8 billion years old, no black dwarfs are thought to exist yet. As the Sun enters the red giant phase and eventually becomes a white dwarf, the entire solar system will change dramatically. The inner planets, Mercury and Venus, will likely be swallowed by the Sun early in the red giant phase, leaving behind no trace. Earth's fate is less certain, but it may also be consumed or reduced to a lifeless rock. The outer planets, the gas giants Jupiter, Saturn, Uranus, and Neptune, will likely survive the Sun's red giant phase, but could lose some of their outer atmospheres due to solar winds. Their moons, some of which may harbor subsurface oceans, will also face changes in their environments, with temperatures plummeting after the Sun becomes a white dwarf. Kuiper Belt and Oort Cloud, distant regions of the solar system, such as the Kuiper Belt where Pluto resides and the Oort Cloud, the source of long-period comets, will remain largely unaffected by the Sun's red giant phase. However, as the Sun loses mass during this process, the gravitational influence it exerts on these regions will weaken, possibly causing objects in these distant realms to drift further away. Life on Earth will be unsustainable long before the Sun becomes a red giant. The gradual increase in solar radiation will make the planet uninhabitable within 1 to 2 billion years, as oceans evaporate and the surface becomes too hot for liquid water to exist. However, the question of life elsewhere, perhaps on the moons of the outer planets, remains open. These moons may become more hospitable during the Sun's red giant phase as they warm slightly, but any period of habitability would be short-lived. For any future human civilization, survival would require colonizing planets or moons far from the Sun or finding a way to travel to other star systems. Interstellar travel or colonizing distant worlds might be the only long-term solution to ensuring the survival of life from Earth. The Sun's evolution from a stable main sequence star to a red giant and then a white dwarf is inevitable. Over the next few billion years, Earth's habitability will decline as the Sun grows hotter and brighter. By the time the Sun becomes a red giant, Earth will either be consumed by the expanding star or rendered a lifeless, barren rock. The solar system will continue to change, with outer planets surviving in a much altered form, while the inner solar system will be forever changed by the Sun's transformation. Although this future is far off, it highlights the impermanence of planets and stars, as well as the importance of exploring and understanding the universe beyond our home planet.